So welcome to my video on the law of sines. Up until this point you probably know how to solve right triangles, but now we're going to solve a triangle that is not a right triangle. And one of the methods that we use to solve a triangle that is not right is the law of sines. And I wrote the equation for you for the law of sines in the top right hand part of the screen. It says the sine of angle A divided by the length of side A is equal to the sine of angle B divided by the length of side B, and that is also equal to the sine of angle C divided by the length of side C. And I drew a picture for you here on the left so everything's a little easier to see. I drew the angles in uppercase letters, and I drew the length of the sides in lowercase letters. And let's take a look at this angle A. All right. Notice how the opposite side of angle A is side A, and that has to be true for all the angles. The opposite side of the angles have to be the corresponding letter. The same thing for angle B. Notice how the opposite side of angle B is side B, and the opposite side of angle C is side C. So the point I'm trying to make is that the opposite side of the angle has to be the corresponding side. So let's get started right away with an example. Okay, for this example, let's say that this angle right here is 70 degrees, and let's say that the side that's opposite that angle, we'll say that this has a side of length 10, and let's say that this side over here has a length of 8. And we're going to solve this entire triangle. And let's label this triangle before we start doing any work. We'll say that this angle right here is angle A. So if this is angle A, then the side opposite of that angle has to be side A. So that means that the side with the length of 10 has to be side A. We'll say that this is angle B down here. So that means that the side opposite of B has to be side B. So we know that this side with the length of 8 has to be equal to side B. And last but not least, there's only one more angle left, so it has to be angle C. And the side opposite of C, which is the bottom side, is going to be our side C. Alright, so basically solving this triangle using the law of sines is going to be a bunch of plugging and chugging. Notice how we have the angle A, which is 70 degrees, and we also know the length of side A, which is a length of 10. So this part of the formula is already given to us. Alright, so let's plug everything into that part of the formula. The sine of angle A, which is 70 degrees, so the sine of 70 divided by the length of A, and we know that the length of A is 10, so divided by 10 is equal to the sine of B, which we don't know angle B yet, so we just gotta leave it blank, divided by the length of side B, and we know that the length of side B is equal to 8. So we can divide this by 8. Alright, so now we have an equation, and we can easily solve for the angle B. So we want to get B by itself, so the first thing I'm going to do is I'm going to multiply both sides of this equation by 8. And notice how on the right hand side the 8's cancel out. So on the left hand side we have 8 multiplied by the sine of 70 divided by 10 is equal to the sine of B. Alright, so let's scroll down a little bit so I have a little bit more space. Alright, so at this point I'm just going to plug everything into my calculator. If you multiply 8 times the sine of 70 and then you divide that by 10 and you plug that all into your calculator, you get a really long decimal point. I'm just going to round to 4 decimals. You get 0.7518. All intermediate steps you should probably round to 4 decimal points, and that is equal to the sine of angle B. Alright, but we still haven't gotten B by itself. That's what we're trying to solve for angle B, and we still have this sine in front of it. So in order to get rid of the sine, you got to do the opposite, which is the inverse sine. Alright, So our angle B is equal to the inverse sine of 0.7518. And if we plug this into our calculator, we get B is equal to the inverse sine of 0.7518. And if we round that to 1 decimal point, we get 48.7 degrees. The inverse sine of 0.7518 is 48.7 degrees. So now we know our angle B. So let's plug that into our triangle. We know that angle B is equal to 48.7 degrees. Alright, so now I'm just going to clear up some space to give me some more space to work. Alright, so now let's solve our next part of the triangle. Notice how we have two angles of this triangle solved for, and we know that all three angles of a triangle are equal to 180 degrees. So we know that angle A, which is 70 degrees, plus angle B, which is 48.7 degrees, plus angle C, which we don't know yet, are all equal to 180 degrees. Once again, the sum of all angles in a triangle are equal to 180. So now we can solve for angle C quite easily. If we just add 70 degrees with 48.7 degrees, we get 118.7 degrees, plus C is equal to 180. Once again, we want to solve for C, so we want to get rid of this 118.7, so I'm going to subtract 118.7 from both sides. On the left hand side they cancel out, and we get C is equal to 180 minus 118.7, which is equal to 61.3 degrees. So we know that angle C, I'm going to put this in our diagram, angle C is equal to 61.3 degrees. And once again, I'm going to erase some stuff so there's more room to work. Alright, so now there's only one piece of the triangle that we don't know yet, and that is the length of side C. So now we're going to solve for the length of side C. Alright, so we know that the sine of angle C, and angle C is 61.3 degrees, divided by the length of side C, which we don't know yet, that's what we're solving for, is equal to the sine of A, and once again we know that angle A is 70 degrees, over the length of side A, and we know that the length of side A is equal to 10. Alright, so we need to solve for C, so I'm just going to get it out of the denominator first. So I'm going to multiply both sides by C, and on the left hand side the C's cancel out, and the only thing we're left with is the sine of 61.3 is equal to the sine of 70 divided by 10, and this is all multiplied by C. I'm going to scroll down a little bit just to give myself a little bit more space. And once again, we're solving for C, so we need to get C by itself. So I'm going to get rid of this 10 and the sine of 70. So I'm going to multiply by 10, and I'm going to divide by the sine of 70. And whatever you do to the right hand side, you have to do to the left hand side. So I also have to multiply by 10, and I have to divide by the sine of 70. Alright, and notice on the right hand side how the 10's cancel out and the sine of 70's cancel out. And on the left hand side we're left with 10 divided by the sine of 70, all multiplied by the sine of 61.3, and that is equal to the right hand side, and the only thing we have left is C on the right hand side. Alright, so now in order to solve for C, we just need to plug the left hand side into the calculator. If we take 10 and we divide that by the sine of 70, and then we multiply that by the sine of 61.3, we get 9 0.3, and I rounded that to 1 decimal point, and that is equal to C. And now we know that the length of side C is equal to 9.3. So if we go back to our diagram, we know that C is equal to 9.3. So now we have solved our triangle completely. We know that angle A is equal to 70 degrees. We know that angle B is equal to 48.7 degrees. We know that angle C is equal to 61.3 degrees. We know that the side of length A has a length of 10. We know that B has a length of 8. And we know that side C has a length of 9.3. So I hope you enjoyed this video. I will be making a video on the law of cosines coming up, so stay tuned, and I will see you in my next video.